Right guys, today we're going to do an LS430 2000 to 2003 using an automatic gearbox and a brand new harness built for any swap. So let's get into it. Right, so as discussed, this is an LS430 2000 to 2003 that makes it the 3UZ with the 5-speed automatic gearbox. This is a completely brand new harness built to use the automatic gearbox and obviously bring the ECU and the fuse box and everything inside the vehicle where they'll be nice and waterproof. So what we're going to do today, we are going to go through the layout of the harness first so the customer knows exactly where everything plugs in. We're also going to go through the connectors on the fuse box so the customers need to connect inside their vehicle. Once we've done that, we're then going to jump into the testing side. So that's going to be testing with the ignition on and with the engine actually running as well. But as it's a brand spanking new harness, we're going to go through the photos of what it looks like when we build it up, and it is a modular harness, so we're going to go through those little sub harnesses that make up the entire harness. So let's do that now. I'll be back in a second.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life. I never miss, that's fact, taking big swings, put your hand to the bat, put me in the ring, you'll go out in a bag, cause I sing what I mean and I bring it to the mad light. Ain't got time to kill, I got time to feel, I took the red pill, I know life's short so I wanna live real, but how's it supposed to feel? How's it supposed to feel? How's it supposed to feel? They wanna say my name, but they holding back. They wanna say they hate, but they know it's cap. I ain't play no games, I just do that's fact. And I don't feel no shame, it's a mood you lack. I go crazy, nah, but I ain't lazy. Track after track, I work on this shit daily. Pass me the jack, right as fuel, got me hazy. About to unpack all these things I've been chasing. I've got visions in my head, like memories after death. To be a legend instead of something you can forget. I'm living up every breath, I'd rather lead than be led. I'll fill the seats as I spread with every word that I've said.
Right, so now you've seen exactly what goes into making one of these and all the little sub harnesses that make up the entire selection of the harness. So as I said, first thing we're going to do is we're going to go through the entire layout and then we're going to do the connectors on the fuse box that the customers need to connect. So starting right here at the ECU, it's really, really nice and simple. You've got your 3 plugs that are related to your actual engine harness itself. You then have one section that pops out over there, makes its way around and plugs directly into the fuse box. That's all the powers and everything that are required for the harness. Then we have our ECU body plugs. So these are the 2 on the outer edge over here. Most of the wires come down through there and they go into the fuse box, again supplying all the powers and everything that are required for the ECU. We then have our pedal plug sub harness. So that is again a little 6-pin DTM plug on there. A nice 2-meter long harness over there, which then goes up to the pedal that the customer is going to use inside the vehicle. So 2 meters should be plenty enough to run it from this side over to that side of the vehicle over there. Right, so that is that section over there. Again, nice and simple. All these 5 plugs are completely unique. You can't put the wrong one in the wrong place. Obviously, the way the harness is built, again, determines pretty much where they go. In terms of the plug on the fuse box, again, you have 4 plugs. All of them are unique, so you cannot get them mixed up. We'll be back to look at these 2 plugs over here, and that's going to be part of the section where I go through all of that. Moving along from there, we're going to then get to our grommet, and in this case you can see we don't seal up the grommet because we like the customers to have the flexibility to move the grommet wherever they deem fit, depending on their particular swap. And obviously then they can heat shrink this SCL down, so it's an epoxy lined heat shrink, so once it's sealed it'll make the harness nice and watertight in terms of being from the engine bay. Moving up along there, we then have our T-piece molded boot from Raychem, and that then splits the harness up. So we're going to go along the front here and we are going to go back over there. What I'm going to do is we're going to go through this section first coming here. I'll come back and then we'll start looking at those sections that pop out over there. So straight out of here, we then have the main harness that runs along there. We also have our ignition harness. So again, what we've done is we've made the ignition harnesses on a completely separate sub harness. So you can basically unplug here at the 8-pin DTM connector. You can unbolt all of these coils, pull them all out as one, and you don't have to physically disconnect each individual plug itself. Okay, makes it nice and simple. Also, when you guys sometimes want to go to aftermarket ECUs, or even if you sell the harnesses on and people want to go to aftermarket ECUs, it also means they have the functionality to change the coils out for whatever they desire. So that's a nice feature there. Moving along here, we're then going to have a breakout right here in the middle, and that's going to go to our cam sensor for our left bank. So do remember, this is the left bank, always from the driver's view. This is the left bank, that is the right bank. This has cylinder 1, 3, 5, and 7. That has cylinder 2, 4, 6, and 8. And as you can see there, they're labeled there ignition 5. Trying to get some light without blinding you, and you can see that should be labeled ignition 1 over there. So all of these are labeled nicely for you guys so you can't get it wrong in terms of fitting. Right, so moving along from there, it then's going to carry on down through here, and it's going to break out here by the injector at the front, and then it's going to go to the oil control valve for the left bank. So this is the oil control valve that controls the degree of the cam for the VVT-i. Okay, so that's what this thing does. Again, they are labeled as OCV, or oil control valve, because again, the cams are controlled via oil pressure, and that's how they're advancing and retarding the cams for the VVT-i. Also breaking out here is going to be your front cam sensor. So again, these can be cable tied down over here, which is a mount designed for the harness on these particular engines. That goes out and it plugs directly into there. That is obviously labeled as cam. So again, nice and easy to find that out. Then moving along, the harness makes its way down here, and you'll see you have mounting points here and here to obviously keep the harness out of the way of anything. Remember, you guys might have an aircon pump over here, so obviously ours is missing. So again, that belt runs all the way across there like that, and so therefore this keeps the harness out of danger's way. Coming to there, we then obviously have the breakout over here, and this is going to break out into 3 sections for you. So the first one is going to be to our Lambda sensor. Now the Lambda does actually fit through this hole over here, and it can pop out down there and make its way to the Lambda over there. So there's many ways to do it. That's probably a better way because it's going to keep it away from the exhaust. So the reason we actually bring the Lambdas out here, or O2 sensors out here, is because they used to come down through there and be very, very close to the exhaust. So connectors and everything fail a lot on that side. So obviously we wanted to keep now the connector and the wires away from the exhaust. So bring it down through there, plug it in there, no problems. Also coming out here, you'll see we have a very, very, very thin wire over there. That is your oil pressure switch. So that goes down through there, out through there, and it plugs in over here. So again, this is an actual LS430 engine from 2003. So this is what the customer will have in front of them when they are doing it. But we have made the cable breakout over here, because if this housing doesn't work and they need to move it back and slightly closer in, you can get like the GS430 or the SC430 oil filter housings that move it back here, and the switch is at the back over there. So that's why it's broken up over here, so it can come down through there, go to oil pressure switch over there, or go over here. So you're not limited on which one of these you can use. That oil pressure will fit with both styles of oil filter housing. The last thing to break out here is going to be your crank sensor, and again, it goes through that hole, down through there, and plugs directly into your crank sensor there. Again, everything is labeled, so don't stress too much about trying to figure out where it all goes. But yeah, nice and simple. Now, if your aircon pump is on here and you're just leaving it to act as idler or whatever, you can actually get the cables through there with the aircon pump in. It's just a little bit tricky. You kind of got to feel it going blind, but you will get everything through there like that. Right, so that's that complete side down to there. Let's come back over here and let's start looking at what is coming out over here at the back. So there are quite a few little sections over there. I'm going to start with the nice easy stuff. So first of all, we have this ground. So that goes into the M6 hole over there. So obviously that's an M6 bolt that's going in there. This is the only ground for the entire harness. So this is the one you're going to attach on there. The hole is only big enough for an M6, so these holes down here are not going to be applicable, but you wouldn't have bolts in these holes anyway. You would only have these ones because this is where the original engine harness actually mounted its ground to. Coming up to the top here, we then have our second little sub harness section. That's going to be for our injectors. So I'm going to put a link up in the top there, and you're going to see exactly how to fit that injector harness on the engine itself, but it runs through there. It also plugs into the IACV, or no, it's not IACV, ACIS control solenoid underneath the intake there as well. But as you can see here, they pop out through here and they go to all of the injectors over there. So it's 1, 3, 5, and 7. Again, all labeled for you guys, so you don't have to worry about knowing which one goes where. And it clips into the original sort of mounting points that you'll see underneath there as well. Okay. Next up is what I call the sub harness because it goes underneath the intake. And what I'll do is I'll cut to a photo now because it goes under the intake, and then you'll see it goes to the 2 knock sensors, and then it goes to the starter solenoids. Right, so getting back over to here now. The last section to come out of here is going to be the gearbox harness. So that's going to run down along here. We're going to have our first breakout over here, and basically what's going to happen is your selector, which is this one over here, is going to break out to go over to that side because that's where your selector is. Then your input speed sensor is going to be on this side because that's the one that's just over here. So the harness is designed to come down and go sort of along this way like it was standard. So that's going to be your input speed sensor that plugs in there. Then you have another section of harness that goes down there, has another breakout at the back, and that's where your 12-pin solenoid plug goes. So that's at the back of the gearbox on this side. And then you have your output speed sensor again that goes on the back of the gearbox on that side over there. So that is all of that. Really, really nice and simple. Okay, so that's that section over there. The harness obviously just makes its way over the back, so I'm going to nip over to the other side so we can carry on from there. Right, so moving along there, again, you can see we're using a P-clamp just to mount it on a mounting point on the original black plastics that went across the back here, so we're just using those mounting points to hold it all down. At this breakout where this P-clamp goes, you have your next ignition sub-harness. So again, it's exactly the same as the one on the other side. It just breaks out and goes to all 4 ignition coils. Again, nice and simple. So if you want to do a service on it, you can literally just unplug that, pull all the coils out over there. I'm just actually using a cable tie just to hold it to the other main harness that's running along through here. So you guys can do that as well. It looks nice and neat when you do that. But the harness that goes underneath goes further along here and it breaks out here to go to the cam for the right bank. So you'll notice now that I've gone through 3 cam sensors. That's how much this engine has. Same with the 1UZ VVT-i. So you've got the one at the front. That's telling the ECU where the engine is in relation to doing spark. Obviously, it's telling the position of the engine because that is a static cam position, aka the VVT-i moving. It doesn't affect that cam sensor. These 2 on the inlets, those are measuring how much the cam is advancing and retarding based on what these oil control valves will do. So it's nice and simple. All it basically is the ECU will command these oil control valves to set a certain target of either advance or retard of the cams. These are then measuring that, so that's why you can get an error to say that obviously your camshaft is no longer doing what it's supposed to do, and the ECU can pick that up. All right. So moving along from there, we then have a breakout at the front over here. Quite a few sections going on there. I'm going to start from the top here. So we have our coolant temp sensor. So that goes directly in there. Now on your 3UZ, this section where I have a temperature sensor is actually going to have a bolt in there. Okay, it's actually a blanking bolt. So, but it is a really nice place if you want to fit a coolant temperature sensor for an aftermarket gauge. Now, a lot of you do that, and what we've done is we've created this wire called Temp with a long stretch of about 5 centimeters of wire, so you guys can cut, strip, put the correct terminal on for whatever temperature sensor you might need for inside your vehicle. Whether you want to use the temperature sensor that was designed for your vehicle, so some older vehicles had a dedicated separate temperature sensor, like the older 1UZ non-VVT-Is had, and that was designed for the gauge in the car. So we've added this in so that you guys can put a temperature sensor in there, and when we go through the connectors over there in a minute, you're going to see where that comes out by the fuse box. Then we have our throttle sub harness again. So it's a 6-pin DTM plug, and that's designed to then do the throttle. So you've got your 2-pin plug over here. That is your actual motor, and then the harness snakes around the top over there, makes its way down through there, and then plugs into the TPS. Now you can run that harness underneath the throttle if you want as well. There's plenty ways to do it, so don't stress. Whatever you like the look of, that's what you want to fit it with basically. And again, so this also makes it nice if you want to remove the intake manifold. You can effectively just unplug the entire throttle from there, remove your air pipe, some of your coolant pipes over there, and unplug your injectors, and you can remove the entire inlet manifold without having to unplug a single standard Toyota connector. So that is a very nice feature because these connectors like the injector plugs and all of these ones over here, they're actually not rated for a lot of connect and disconnect cycles. As a matter of fact, those ones on the coolant temp sensor and the TPS, the super sealed connector series, according to the paperwork, they're only rated for 10 connects and disconnects, and technically they're supposed to be replaced after that. So the fact that these DTMs have hundreds of cycles of connect and disconnects. Makes them really nice because if you've got to be working on the engine, to just basically plug your injectors in and forget about them. Then you can unplug the plug at the back, remove the whole inlet manifold, no problems at all. Put it all back and plug 2 plugs in and your whole inlet manifold is back and operational again. Okay, so that's that. And then we have our oil control valve for the right bank over here. So again, exactly the same as the other side. This is what's making the cam advance and retard via oil pressure over there. Also coming out here is your mass airflow sensor. So you see this nice long wire that snakes its way up there, and that is going to plug into there. So remember, on a 3UZ, you should have this style of MAP sensor. Now, just a quick note for you guys. There is a difference electronically with the SC430 mass airflow sensor. Also, the plug is slightly angled upwards, but also the GS430 is slightly angled upwards. So always make sure you get the correct mass airflow sensor for your particular setup, and more specifically on the SC430 as well. Right, the harness then moves down along here, and we have another breakout over there, and we have our alternator sub harness, and we have our Lambda harness. So that actually goes onto a bracket over there. Nice and straightforward. Alternator plugs directly in there. This obviously is an LS430 alternator, so this is exactly what you should have looking at. But remember, the reason we put it on a sub harness is multi reasons. Sometimes guys want to move their alternator. So in this case, the alternator I think is actually going to be flipped around. So the body is going to be over here as well. So what we're going to end up doing is probably making a different harness for the customer with a different length, depending on how this sort of gets itself set up. But again, it is quite a distance here. So if it was the other way around, he might actually probably still reach with this one, but we'll go through that with the customer when the time comes. Obviously, we keep these little harnesses in stock, so they are readily available. All right, so that is pretty much the entire harness. Like I said, everything is labeled, so it's really, really straightforward. Just remember, your T-piece molded boot is where the harness splits off to go around the different sections of the block. It makes a U shape. It's relatively straightforward, and everything is labeled. And normally what I normally do is I just put all of my sub harnesses on, you know, your injectors and so on and so forth. Then I put it all together and I drop the main harness over, and then I just start plugging everything in. Okay, so it's really, really nice and super simple. Okay. Right, so again, super easy. So what we're going to do now is we're going to pop over and we're going to start going through the 2 connectors that are on the fuse box for the customers to connect. All right, now 9-pin plug. Again, if you've watched any of our other videos, this is going to be so repetitive for you guys, but I'm going to go through it for the customer. But yeah, it's the same plug we use pretty much on every single harness. So the first pin is a red 14 gauge or 2mm squared wire, if you want to call it that. That is your main power for your fuse box. Now, on the instructions that come with every harness, it does need to be connected to permanent 12-volt supply. Now, the reason it needs to be connected to permanent 12-volt supply is the ECU doesn't store codes in some kind of volatile memory. So the second that you disconnect the permanent 12-volt supply from the ECU, it resets. Literally the second you disconnect it, it resets. If you were to connect this red wire to an ignition source, every time you turn the key off, the ECU is going to reset. Now, some might say, well, I'm not too worried about that. But the problem comes when you need to diagnose an issue, because the ECU will not be storing any codes. You'll be looking at the live data via the OBD2 machine, so things like long-term fuel trims, etc. They'll all be reset. So effectively, you want to keep that permanent power supply so that basically you can help with diagnostics and make your life super easy. Okay. Now then, the next wire that we've got is number 2, and it is going to be our black with a yellow tracer, and that is your start signal. So that requires a 12 volts. Okay. Now it does have to be a 12 volts in this case, and obviously mainly you guys are using ignition barrels on existing vehicles when you are doing these. That's a signal you're going to be getting anyway, so it's not too much of a drama there. So again, nice and simple, but this little wire is just a little 20 gauge wire. It's really, really thin. Remember, that's not actually controlling the starter motor. The starter motor is relayed as part of the fuse box. So the actual proper current carrying capacity is taken care of in the engine harness. You are simply just activating a relay with that. So that wire can be 22 gauge, 20 gauge, whatever thinness. It not going to affect the way it operates. Number 3 is going to be yellow with a green, and that's temp. So remember we spoke about the temp wire that we have here loose for you guys to use if you want to. Well, that's where it comes out. And you'll see that basically I've connected it to our 1UZ-FE non-VVT-i temperature sensor. That's the one that's bolted in there. And it's going to go to our little device here, and it's going to translate onto our dash over there. So we can see that that yellow with the green wire is connected correctly in the harness. Next up is going to be number 4, and that is going to be our gray 16 gauge wire, and that is for your fuel pump. So in this case, the ECU controls the fuel pump. I'm going to put a link up there. I've done a really nice video. I please do recommend you go watch that, because we get asked the question like, I've supplied power, the fuel pump's not priming. That's the way they work. But in that video, I explain it in much greater detail for you. But the ECU is controlling the fuel pump. There's a relay inside the fuse box for the fuel pump. That gray wire is what you take directly to the positive of your fuel pump. Okay. If for whatever reason, you guys want to run 2 fuel pumps and you think that that's not going to be enough current draw, because it's only fused at about, I think, 20 amps or something like that. That should be plenty for a single in-tank fuel pump. But if you need more, then you can just use the gray wire as a trigger for a set of relays that you can put by the tank, and therefore run the fuel pumps directly from your own relays and just use that as a trigger. But if you're only using one in-tank pump, that should be plenty enough for you there. Try and keep it around 14 to 16 gauge when you're running it along, just because of voltage drop. Next up, number 5 is going to be yellow with a red tracer, and in my case it is connected to our cluster over there. That is our check engine light. That's going to light up our check engine light. We also actually have a check engine light in the fuse box in the form of an LED, so we do put that in there for you guys just in case you don't get around to actually connecting it on your cluster, and that way you can still see that the ECU is turning on and so on and so forth in terms of that. So it is giving out a ground signal, so please be aware of that. And obviously when you're using like an LED or something like that, you want to feed ignition 12 volts to the other side, and then our yellow with the red tracer wire to the negative side of the LED if you're fitting LEDs to make a check engine light. Next up is number 6, and that is yellow, just straight yellow, and that is your tacho signal. So your rev counter / tacho signal is coming from the ECU. It is a 4-cylinder signal, so please be aware of that if you're using aftermarket gauges, that you need to set it to 4 cylinders in order for it to read correctly. That's why when we come to start the engine, I'm feeding the tacho signal directly to my cluster. That's obviously designed for a 6-cylinder, so if you look very closely, the RPM won't match. It'll be slightly less on the gauge than what's actually coming out of the engine. Obviously, you're wondering why it's a 4-cylinder. Maybe you're not, but if you're wondering why it's a 4-cylinder signal, it's actually a legacy thing left over from the non-VVT-i. The non-VVT-i had 2 igniters and basically treated the V8 engine as 2 separate cams. So you had 2 coils, 2 igniters, 2 distributors, 2 everything. And because the rev counter signal came from the igniter, one igniter was controlling 4 cylinders. Therefore, it had a 4-cylinder signal. And that just kind of carried on. Even though these are coming directly from the ECU, that just carried on. There was no need to a 4-cylinder signal, but they just did anyway. Probably manufacturing all their clusters. Again, if you've got a company with 4 cylinders and 6 cylinders and 8 cylinders, why not make the 8 cylinders give a 4-cylinder signal? Then you can use a 4-cylinder signal rev counter for both a 4 and an 8-cylinder engine. Makes sense from that point of view if you think about it. After that, we got number 7, which is black with a red tracer. Now that is your ignition feed. So that is the one that you are going to be taking from your key barrel or a switch or however you plan on doing it. Now then, if you are going to use a key barrel, please be aware of something. Key barrels have accessory and ignition, 2 different sources. Now what's important about that is accessory loses its power when you go to the start button. So have you ever noticed in a car when you turn the key to start, things like the radios turn off? Basically they're fed by accessory. Now if you feed this black with a red wire with accessory 12 volts, what's going to happen? The whole ECU and everything's going to shut down when you move the key to the start position. What's going to happen then? It's not going to start. And it's going to be the most frustrating thing to diagnose, because the second you let the key go, everything's going to light back up again and you're going to think, what the hell is going on? And if this is on the other side of the vehicle and you're on that side trying to crank it, you can't see that the light is turning off when you crank it. Okay, so please make 100% sure if you're using a key barrel, find the 12 volts. There'll be 2 12 volts, one accessory, one ignition. Okay, when you're in the ignition position, okay, move the key to start. If the 12 volts stays on the wire that you're checking, that's ignition wire. If the 12 volt goes away when you turn the key to start, that's accessory, and do it accordingly. And so connect R1 to the ignition, not the accessory feed. Right, next up is going to be number 8, and that is going to be pink with a blue tracer. Now that is our our alternator light. Apologies for that. That is coming directly from the alternator, from that 3-pin plug. It gives out a ground to activate your charge light. So in our case, we're going to be seeing our charge light and our oil light appear on here when I turn the ignition on, later part of the testing. And so basically that's how it works. Some things you must note. If it's a very old vehicle that you are working with and you're taking it directly to a cluster, they have a tendency sometimes to backfeed through that, which then makes its way directly to the alternator, which then keeps the regulator on, and sometimes even backfeeds into the fuse box and keeps the system alive. Okay, so How do we remedy this? There's one of two ways. Number one, we can fit a diode in the wire to make sure that there's no backfeed of current from the cluster to the alternator, okay? Second of all, you can replace the bulb with an LED. Why? Because an LED is a diode, so it does the same job. So you basically then are restricting the way the energy flows, and therefore you can't backfeed into the alternator. All right. So those are your two options really that you can do. If you are having to fit separate lights for things like oil, alternator, check engine light, etc., then just make sure the LEDs. That solves all your problems in one go. Okay. Then last up is going to be number 9, which is yellow with a black, and that is our oil pressure switch. So that's connected to the oil pressure switch that is down over there. All right. Again, nice and simple. It's just a ground signal. That's all. You can take it to your dash and so on. There's no worries about feeding back because it actually has nothing to do with the ECU whatsoever. So your charge light and your oil light doesn't go anywhere near your ECU at all in these particular applications. So there's no feeding back in or any issues with the oil light. It's just the alternator light that you need to be careful of when you are doing that. And it happens more than you think where the cluster is actually backfeeding and causing issues from there. Most modern ones are using LEDs anyway, so you don't have that issue, but it's the older ones that cause the problem. Okay, so that is our 9-pin plug. So now we're going to move over to our 12-pin plug, because as this is an auto, we have some gearbox wiring that you guys need to take care of. Well, actually, you don't need to take care of, to be honest with you. But it's nice to have, and it gives you some of the creature comforts that you'd be used to if you've had an LS430 or any sort of Lexus V8 auto version. All right. So number 1, 4, 7, and 10, which is this top row over here, that's just your OBD2 connector. Okay. Nothing you need to do there. There's your OBD2 plug. You plug it straight into a reader of some description. You'll be able to get all of the live data. That's no problem at all. We'll start with the rest now. So we've got number 2, which is white with a blue tracer, and that is your brake switch. So you need to supply 12 volts to that when the brakes are pressed, okay? The Lexus system actually uses a 4-wire brake pedal, but that is all taken care of in your fuse box. It's actually done with a relay, so you don't need to stress about that. All you're gonna connect is literally the 12 volts when your brakes are pressed. Now, it is fused inside the fuse box, so don't worry about where you get it from. It can never do any damage to the ECU because the fuse will blow before that happens. So you can either connect it literally directly to the feed that goes to your brake lights. That will supply 12 volts to turn your lights on. And sometimes that might be the only option because not every single system in terms of the brake pedal actually runs the 12 volts through the brake pedal. So you might have a system where actually it's a ground signal from the brake pedal to activate something else which turns on the brake lights. So just be wary of that. You need to supply 12 volts to that. And basically that tells the ECU when the brakes are pressed and not pressed. And that helps again with sort of slowing down and so on. So it is quite useful to have that connected, but by no means are you required to connect it, okay? Next up is number 3, and that is orange, and that is going to be 2. So that's going to supply 12 volts when the gearbox is in 2. So remember, you've got park, reverse, neutral, drive, and then 3, drive, 3, and then 2, okay? So when the gearbox is in 2, that orange wire is going to have 12 volts. Okay, now it'll become apparent why I put that in there in a minute when we go through it, but we'll get there in a second. Number 5 is going to be red with a yellow, and that is your cruise control switch. So because this is staying auto, it's got the speed signal from the gearbox, so it knows how fast it's going. So you can have cruise control. It's really, really nice and simple. You just need to get a cruise control switch from 2000s Toyota or Lexus and fit it inside your vehicle. The little stalk that goes in there. The other side needs a ground. And then you connect our wire, which is the red with a yellow tracer wire, to the other side of that cruise control switch. And voila, you have cruise control. Just follow the commands of the actual switch itself. So like turning on, speed up, speed down, etc. It's all taken care of as part of that. Number 6 is solid yellow, and that is going to be drive. And what I mean is that's going to supply 12 volts when the gearbox is in D or drive, okay? Now, again, I'm going to get to why we have those 12 volts. I will explain that in a minute, but I just want to go through each why so you know exactly what's there. Number 8 is going to be black with a red tracer, and that's going to be reverse. Okay, so you do need that for your reverse lights if the vehicle is going to be on the road. So that's what you can use to power your reverse lights, and that is really simple and straightforward. Number 9 is going to be a solid red wire. Now then, this is called L or low. Now, if you are familiar with the LS430, SC430, GS430, any of that sort of era of vehicles, especially in this case, the 5-speed automatic gearboxes, even the LS400 VVT-i 98 to 2000 had it. But the gearbox actual select inside the car goes park, reverse, neutral, drive. Then it goes sideways to 4, or manual in some cases. Then it goes down to 3, 2, and then it goes sideways over to L. So 4 and L are actually electronic signals via micro switches that are built into the shifter. Okay, so I'm supplying you with all the wires that you could actually take to the Lexus shifter to make that system work exactly as it intended to. Okay, and that's where the 12 volts and the drive 12 volts come into play. So on this one, which is number 9, which is red, which is L, that needs to be supplied 12 volts via the 2 wire, and that'll then keep the gearbox in L, or first gear, or low mode. Okay. The reason we use the 2 is that basically what it happens is if you guys end up using switches in order to control the L and the 4, what is important is that basically if you use the 2, if you look at the way the shifter's positioned, 2 and L actually have 12 volts at the same time in the ECU. So it is expecting to see that. If you moved from L to sideways to 2, and then you went up to 3, then 2 and L would no longer have a signal. Now, if you're using an aftermarket shifter where you go down to 2 and you don't actually press sideways, but you're pressing a switch to keep it in L, then basically what's going to happen is if you used an ignition 12 volt source, if you moved up to 3 without consciously thinking about turning the switch off, then the ECU is going to have 3 and 2 and L having 12 volts at the same time. It doesn't like that. It freaks out, and then obviously you get issues the way it runs. So if you use 2 from our plug, via a switch to do L, if you move the gearbox from 2 to 3, well, what happens? Now the power that supplies your L or your 4 switch gets cut off. So you can never have 3 and L having power at the same time, and you can never have 3 and 4 having 12 volts at the same time. All right. If you use the selector that's actually in the LS430, you also are required to connect D and 2 12 volts to that shifter. So that's also why we put that in. But it also does the same job that Toyota wanted to do, which is basically make sure that the correct signals are received at the correct time. So that's why it's important to use those, so that you don't have a situation where the ECU sees 2 gear positions that are incompatible. So drive and 4 should have 12 volts at the same time. And when you do that as part of the testing, you'll actually see that drive on the tech stream turns off and 4 becomes active. And then as soon as I let it go, the 4, then obviously drive becomes active and 4 turns off. So the ECU recognizes that those 2 inputs should be active at the same time. And if they are, then the gearbox is in 4. Right, and that brings me then, I'm just going to go over to number 12 here quickly, because that is the blue with the red, so that is your 4. So your blue with your red, your 4, needs to get power from your yellow, which is your drive signal, via a switch if that's what you're doing. Your red, which is L, needs to get power from your orange, again, because orange is 2, red is L, if you're using a switch. If you're using the selector switch, you need to connect the orange and the yellow wire to the selector, and you also need to connect the red and blue with a red tracer, and that'll be your L and your 4. The only other wire that's in the plug now is number 11, and that is going to be your kickdown. Now, I want to make this very clear for the guys that are watching, because we have guys from all over the world. This is a European-only thing. Okay, the JDM and the American USDM ECUs do not have an electronic kickdown switch. This is European only, so please be aware of that. Okay, so that, again, is a very, very, very simple switch that you can put behind the accelerator pedal, and as long as it makes contact when you have your foot flat to the floor, then it will work. It just needs a ground, so all you're basically doing with that switch is one side goes to ground, other side goes to our white wire that's on there, and that's your kickdown switch. Okay, so again, I'm already at 30 minutes, so again, these automatic ones take a long time. I do appreciate that, but there is a lot of wires to go through, a lot of explaining to do as well. I do put it in the welcome pack, but again, I find it much easier to explain to you guys by talking you through it. So what I'm going to do now is I'm going to cut, we're going to come back, we're going to do all the testing, which is made up of 2 parts. One with just the ignition on. We're going to go through all these gear positions that I just spoke about now, but it'll be much quicker when we do that. And then obviously we're going to get the engine actually running as well. So bear with me, guys. I'll be back in a second and we'll get on to that testing. Right, guys, so now we're going to be doing the testing of the harness. And as I said, it's broken up into 2 sections. One with just the ignition on and the other one with the engine actually running. First thing I'm going to do is I'm going to go through the entire list of what we are going to be testing, so you guys can have a familiar with what that is going to be. Then we're going to jump straight into doing the test with the ignition on. So with the ignition on, we're going to be looking for the check engine light. So I want to make sure the LED on the fuse box lights up, and I want to make sure the check engine light on the dash lights up. We also want to make sure that the charge alternator battery light pops up over there, and the red oil pressure switch light pops up on there as well. So those are the three things we're checking there. Then we're going to move over to the OBD2 TechStream device, make sure that that is communicating, make sure it picks up that it's an LS430, and make sure that we can see live data on there. Once we're in there, we're then going to test the fuel pump relay. So as I said, the fuel pump is controlled via the ECU. Earlier I put a link up to a video for you guys, so you should be able to know exactly how that works. I'm going to go in the machine, activate the fuel pump relay, it's going to click, pump's going to turn on, nice and simple. Then we're going to go through the gearbox selector wiring. So effectively I'm going to go and show you, obviously we're park, reverse, neutral, drive. Make sure the signals are coming through as they are. We're going to test 4 and L as well. Then lastly, we're going to test the brake switch. So I just want to provide the white with the blue tracer wire with 12 volts. We're going to hear the relay click. We're going to see the live data on there, and it's going to tell me that the stoplight switch is now activated. Once that's done, that's the ignition side. We're going to move on to testing with the engine running. Now the starter circuits, the reason I put that in there for the autos is effectively the way that the standard system works is the engine will not start unless it's in park or neutral. We replicate the system in its entirety, so I want to make sure that if I move the selector from park to reverse, we try to start it, nothing will happen. I'll then move it back to park, and then we'll go and we'll start it up, and we know that that system is working as we expect it to. Once the engine is started, we're going to move over to here and we're going to test the ACIS valve. So this should literally go like that once a few seconds after the engine starts. Okay, I've done a really nice video explaining the ACIS system. I'm going to put a link up in there and in the description, and it shows you exactly what it looks like in here. I actually pull a whole intake apart so you guys can see every detail of how that works. Now that is incredibly important for low end torque, so if that doesn't work, you need to get that rectified. And I always advise people, when you've got the intake manifold off and you're fitting the injector/ACIS harness, because you physically got to put the connection onto the ACIS, you may as well test it at the same time. It just requires 12 volts and a ground. So get the intake out, get a little battery or something on the table, supply 12 volts and ground. It is polarity sensitive, so one way will work, one way will not work. But if you try both ways and you get absolutely no click out of it, then please replace it now, because once you put everything back together, you're going to kick yourself if it doesn't work and you have to take all the intake back off again, and you could have spent 5 seconds just checking while you were there. Okay, so that's the ACIS. Then we're going to test the drive-by-wire. So all I want to do is literally press the pedal, make sure it works. Nice and simple like that. Then we're going to test the oil control valve. So I'm going to use my machine to activate both oil control valves, one bank at a time, and then it's going to make the engine run lumpy by advancing and retarding the cam. And therefore I know that the oil control valves are working. Okay, there's actually quite a nice test if you guys, because there are filters for the oil control valve. So if there's not enough oil pressure getting to them and you have access to TechStream and you can do this test, sometimes it's useful to know, in which case you might want to take the filters out and clean them. But of course it is a major job with these, because it does require removing the cam covers and actually removing this cam cap over here. So do bear in mind, it's a big job before you undertake it. So do test that before you decide to go that route. Next up is going to be injectors and coils. So what I'm going to be doing is I'm going to be removing each injector one by one on this side, then on that side. That's going to then make the engine misfire. That's going to tell me that each cylinder is firing exactly as we expect it to. The reason I move the injectors, not the coils, is a nice little fact for you guys, is if the ECU picks up that one of the coils has misfired, it actually shuts the injector down until the key is turned off and back on again. Okay, so if I had to pull out each coil one by one, it would be a very slow process of basically killing each cylinder until eventually I got enough cylinders killed that it would actually kill the engine in its entirety. But I can remove the injectors one by one and no problem at all. And these injectors aren't even plugged in all the way. Obviously they got new terminals, so they are really grippy and they will keep the engine running, and I can lift them up one by one. Once we've done that and made sure all 8 cylinders are firing, we're going to come back to our cluster over here. We're going to make sure that we've got our tacho working. We're also going to look at the coolant temperature gauge, make sure that's working. And most importantly, as the engine is running, we want to make sure that our battery, oil light have gone out. Our check engine light is going to stay on because we haven't got the gearbox solenoid plugged in. So we are going to have, I think, 7 codes in relation to the gearbox solenoids. Okay. And that brings me on to my last section, which is going to be the diagnostics. We'll make sure we've only got the 7 codes, which will be related to this not being plugged in. We're going to make sure we haven't got any secondary Lambda codes, because obviously they've been remapped out as part of the remap. And basically we should literally only have the codes for the gearbox for that missing plug over there. Okay. Right, so let's jump into the testing with the ignition on now. So first step, let's turn the ignition on. So I've got the black with the red tracer wire. I'm going to pop in, I'm going to give it 12 volts. You can probably hear the relays clicking on in the background there. So as I said, first up is those 3 lights. We want to make sure we've got the check engine light on the fuse box. That's lit up nicely. We've got the check engine light on the dash. We've got the battery light, and we've got the low oil pressure light on there. So super happy with that, all working as I expected it to. Let's move over to the machine now. And so what I said, we're going to check and make sure that we can see live data. So just over here, you can see coolant temp is 46 degrees, 20 degrees for intake air, 15% for throttle. I'm going to go into system select so you can actually see that the device is picking up that it is in LS430. So there you go, nice and simple and straightforward. Next up, fuel pump relay. So all I'm going to do now is pop into active test. I'm going to scroll down. Oh, I don't need to scroll down, but you can see fuel pump relay, fuel pump. If you watched my video earlier, you'll know exactly why that is. If you didn't, you won't. All right, so pop into fuel pump testing. I'm going to push the arrow and you're going to hear the relay click. And you're going to hear the pump running there. Fantastic. Let's turn that off. Right, so we're going to go back to data list now. Okay, so what we want to do is we want to do the gear selector wiring and we're going to do the brake switch wiring. Now, I don't want to cloud my whole system up here with a whole bunch of data that we do not need. I'm going to go ahead and create just a custom list that's going to give us only what we need for now, because it just makes life a lot simpler. So I need park neutral park switch. I need reverse, I need drive, I need 4, I need 3, I need 2, I need low or L, and the last one is going to be the stop light switch. Okay. Right, so as the vehicle is in park, you can see our park neutral park switch is top there. That is set to on, and the lights on the thing is, hopefully you can see that. Let me just see if I can angle that up. So you can see park neutral park switch is now on. All I'm going to basically be doing is I'm going to be moving the selector switch like your gearbox would be, and we're going to go through the gears. So we've got park neutral park switch on, and I'm going to move it into reverse, so you can see reverse is now on. Back into neutral, so you can see park neutral park switch is on. So that goes on when it's in park and in neutral. Then I'm going to move it on to drive, so we can see drive over there is now on. Now what I'm going to do is I'm going to refer back to my paperwork here. I want to activate 4 because 4 is what happens when you move the shifter from drive to 4. So I'm going to take my blue with a red tracer wire over here. I'm then going to push it into the yellow wire over there. And that is then going to give me my 4. So put that over there. Yeah, so you can see now 4 or drive is now activated, is now on. And as I said when I went through the whole explanation now, I'm going to move to the next gear and watch what happens. So I'll move over to 3, and you can see there 4 and drive are now no longer on, and my system has worked exactly as I intended it to. Going from 3, we're going to move to 2, which is over there, and now we're going to move to L, so that's going to be our red. So I'm going to take my 4 out. I'm going to take my solid red wire, which is L, and I'm going to push it into the orange wire, which is 2. And as I do, you can see now L has turned on. And as with 4, I'm going to move from 2 to 3, and you'll see that they both turn off. So there you go. Now I'm back in third, and low and 2 are now off. So my system has worked exactly as I intended it to. So that is fantastic. Okay, let's move it back up to park. So we're going to go our wrong way. Let's go back in. Let's drive. That's going to be neutral, into reverse, then back into park. Okay, now then. Just a little quick tip for you guys when you're business, and I see this so many times, so it happens often. Don't think you don't have to check it, but it is really, really useful. What's nice about having the 12 volts when it's in gear is you can make sure that the ECU sees the correct information. What I mean by that is you can see your selector switch over here. It's got an elongated hole over there. Okay, hopefully you can see that. So when it's on the gearbox like that, you can actually twist it like that. Okay, and that's because the distance between the actual selection. So if I come on here and I can show you there, so even though I'm in park now, you can see the level of movement and I'm still in park. But if I move it to the one end, you'll see that actually goes, it'll go on, and then if I wiggle it around, just give myself a little bit of, okay, right, let's do that. Okay, so I haven't actually moved the selector off of the position of reverse, but there you go. So I can make the ECU see basically no gears at all, okay, by just wiggling that switch a little bit. And you don't hear the clicks that you would normally hear to tell you that you've gone into the next gear on there. So although when you first fit it, you guys are tempted just to go through the gears like chick, 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 and just hear the click, click, click and think, ah, everything is fantastic, everything is rosy. do check this. Get your multimeter, put it on the yellow wire, which is drive, put the vehicle into drive, and then wiggle the shifter around. Make sure that that 12 volt stays in place, okay? And then what you can do is get in the car and just boot it. Let the engine twist under the torque, and let's see that that shifter is not moving in such a way that drive then stops being seen by the ECU. It's super important because the ECU can do really weird things if the gear indication just disappears from the ECU altogether. I've seen it numerous times. That's a really quick, easy test. The wire is right there. Just grab a multimeter, earth, check your 12 volts, just boot the car in a safe environment, don't break any speed limits, and just make sure that that drive stays having 12 volts the whole time. Okay. Next up is brake switch. So again, nice and simple. I'm just going to take my white with the blue wire and I'm going to give it 12 volts. And as I do, you can hear the relay click there. And as I do, you can see stoplight switch goes from off, on, back off again. That's fantastic. Right, so everything I want to test with the ignition on is 100%, so that's great. What I'm going to do now is I'm going to go and probably not wait too long because I see the coolant temperatures are still above 40 degrees and I'm actually showing some coolant temperature on the dash there. I'm just going to quickly offload this video onto the PC, come straight back, and then we're going to jump into the testing with the engine actually running. So bear with me, guys. I will be back in a second. Right, guys, so now we're back and we're going to be doing the running test on the engine, so actually get the engine up and running. So I've been through the list already, so what we're going to do is jump straight into it. And the first thing we want to test is the starter circuit. And what I basically mean by that is we want to actually go and make sure that the starter circuit is working only when the vehicle is in park or neutral, or aka the start park neutral start inhibit switch is as Toyota intended it to be. Okay, so at the moment I am in park. I'm going to click it over to reverse. And what I'm going to do is I'm going to take my black with the yellow tracer wire. I'm going to gently touch it on 12 volts and you're going to see that there is absolutely no starter motor action. So absolutely nothing. Right, I'm going to put it back to park now. Just going to gently touch it quickly and there you go. Fantastic. Okay, so that tells me that the park neutral inhibit switch is working exactly as it intended. So this vehicle will not start unless it is in park or neutral. So time to get my ear defenders on. Let's get this fired up and carry on with the rest of the tests. Rightio. So touching the yellow with the black wire on there. Fantastic. Okay, so let's move on to the ACIS. So you can see that has gone down. Super happy with that. Drive-by-wire test. Fantastic. Oil control valve. So let's go into the active test feature. And we're going to do bank one first. Let's go to bank number 2 now. Yeah, let's go back to data. Right, so I want to do injectors and coils. So let's start here with number 1, number 3, number 5, number 7. Over to the other side here, let's do number 8, number 6, number 4, and number 2. Awesome. Right, so let's go over and we can see we've got our tacho signal, that's fantastic. Our battery light and our oil light have gone out. Check engine lights as well, but that's just the codes that are there. And lastly is the coolant temp. So we can see that the coolant temp has just popped out. Right. Stay there for me. And there you go. We've got the coolant temp working on the dash there, so that is absolutely fantastic. Okay, I'm going to kill the fuel pump just so that we can carry on with the diagnostic section. Fuel pump there. Fantastic. Right, okay, so everything works as I expect it to. Obviously, we've run the engine up plenty of times before, get up to temperature, the whole 9 yards. So yeah, starter circuit fine, ACIS fine, drive-by-wire fine, all control valves fine, injectors and coils all firing on all cylinders, tacho works, coolant temp works. So let's move into diagnostics. So as I said, we don't have a physical solenoid plugged in here. So what we're looking for is we should have 7 codes. Solenoid 1, 2, 3, 4. Then the SLU, SLN, and SLT solenoids codes. And that'll give us our 7 codes. So what I'm going to do now is go into diagnostic trouble codes. And you can see in the top there, we've got 7 codes. So we've got shift solenoid 1, 2, 3. And let's go down and we should have number 4 there. Then we've got SLU, SLT, and SLN. Okay, so those are only because the solenoid is not plugged in. Once the solenoid is plugged in, all the rest of the codes are going to be gone, and you should be sitting on absolutely no codes at all, because the remap gets rid of all the other codes, including the secondary Lambda sensors after the catalytic converter, so you don't need those. And obviously that means you can wire up your check engine light in faith that once that comes on, you do have a genuine issue that you need to resolve. Okay. Right, what you'll also notice is you're not going to have the ability to bridge 2 terminals in the fuse box and make the check engine light flash. Unfortunately for the 3UZ, now do be careful, on the European and the US models, that does not work, okay? Even on the 1UZ VVT-i US models, that doesn't work. On the European one, it does. JDM models, yes, that will work. You can bridge those terminals, okay, and you can get the flashing check engine light codes. So, I haven't completely removed the feature altogether because there are some other things that you can do with it. But if you look at my OBD2 port over here, you'll see pin 13, which is TC, and pin 5 is there, so that's ground and that's TC. So you can still bridge out ground with TC and put the ECU into diagnostic mode. Okay. Why would I leave that behind even for the European ECUs? Because you can still check timing with that particular setup. Okay, so if you take a paper clip, bridge pin 5 and 13 on that particular plug over there, put the ECU into diagnostic mode, get your timing light, wrap it around cylinder 1. I have a Sealy one and that seems to work just fine by wrapping the clamp around the wires. I don't need to take this out and put an old-fashioned bogey cord or a spark plug lead or whatever you want to call it in there. So just depend on your timing light, see what you can get. And if you have a look down here, we've got 0, 5, 10, and 15 degrees. Okay. You can also see down there, I've put white paint on the crank where the mark is. That's just to make it highly visible when you are checking with the timing light. Remember, I use these engines with aftermarket ECUs, and I still like to check the timing on even an aftermarket ECU, even though I know it should be 100% correct. Okay, so that's a nice little technique you can use. So you don't have to pull any of the covers or anything off. If you are under the impression that there's a possibility that your cam timing could be like a tooth off, absolutely fine. Timing light, bridge those 2 pins, whack it on, should be at 10 degrees. If it's not, possibly timing jump. So you can then take the cover off and just make doubly sure before you correct it. But before you even get that far, you can use that technique, okay? All right, just make sure you do remove the pin after that, because as I said, it locks the timing at 10 degrees. So when you get up in the range, you're gonna have absolutely no power. It's gonna run like absolute terribly, okay? So please make sure you don't leave a paper clip in there, okay? All right, but that's it, guys. Pretty much everything on this harness works, or everything on this harness works exactly as I would expect it to. So it's happy to go back to the customer now. He can put it on his vehicle. Hopefully with this video's help on where to connect everything, little things that he might come across that are going to help him work it out. And Simon, obviously what we'll do is we'll visit the alternator section. I'm kind of thinking that one's going to be long enough, but if not, obviously we can just swap it out and make a longer one. I think best thing to do is to get your harness in there and let's see exactly how long it's going to be. Before we can make a longer one, we need to do measurements on that as well. Okay. But for everybody else, thanks for watching, guys. If you do have any questions, please let me know. You can comment down below. You can also get hold of us on Facebook. And at the moment, obviously, we've had a couple of days off for Christmas, so I'm getting back to everybody that I can. So bear with me if it takes a little time to get back to you guys. I do apologize. Obviously, it's just me on my own with guys that help wiring, but they don't answer any questions. So I'm trying to get through as many as I possibly can while still keeping up with all the wiring as well. So bear with me, guys. You're not going to pester me if you send me a message again in a couple of days' time if I haven't answered you straight away. Okay. But thanks for watching, guys. If you liked the video, obviously like. If there's something you didn't like, don't like. If there's something you want to comment down below, if there's other things that you'd like to see, specific questions that you have, please feel free to ask. It's mega helpful for me because I don't know what you guys don't know. If you guys ask me questions that I can do videos on, if it's helpful for you guys, obviously brilliant. You guys can get issues on your swap sorted out. But anyway, thanks for watching. we are going to be jumping onto a 3UZ 6-speed next and going into an IS200. So what I want to do is get this all off, get this off to Simon so he can get on his vehicle, and let's jump onto the next harness, and we'll see you again soon. Bye bye.